All right, hello everyone. This is the webinar introducing the JupyterLab chart editor. It's great to see everyone out here today. So to quickly introduce myself, my name is Jon Mease. I'm a data scientist and a software developer with the Johns Hopkins Applied Physics Laboratory. I've done some various work in different data science open source projects, and I've also become the lead developer and open source maintainer of the plotly Python library, and then recently also become the maintainer of this JupyterLab chart editor extension. So to get started, I'm going to share my screen and okay. So I'm going to give you a little bit of background on some of the components that are related to the chart editor, and then we'll jump into the chart editor itself. So plotly.py is the Python library that we're going to use to build the initial visualizations. This is a library that covers a lot of different kinds of visualization types. It covers different statistical tests, statistical plot types, scatter plots, bar charts, as well as more advanced scientific charts and areas in finance and also geographic charts. This breadth of visualization types is one of the areas that personally attracted me to Plotly in the first place. And the ability to make all these from Python is a really powerful starting point. The next piece I want to just introduce quickly is something called Chart Studio. So this is a tool that has been available for some time now through Plotly's online cloud service, plot.ly. And it allows you to create all these different chart types using this graphical point-and-click interface for building the charts. So in contrast to having to use Python to build the charts, this allows people to build charts interactively using this graphical interface. And you can use this for free online with the normal Plotly account, and you can upload your own data and build charts through the cloud service. You can make modifications to visualizations, things like that. So this has been around for a while, and the reason I'm mentioning that is that there's a lot of technology now shared between this existing project and the JupyterLab extension. And so this project to do the chart editor was recently rewritten and released as a new version. The Plotly team rewrote all of these components that edit the plots. And it took them I think over the course of about a year. And then in this past month, in September, they released this new version. And one of the motivations for the rewrite was to build this as an open source library that could be used not only in the online Chart Studio, but could also be used in other contexts, and including the JupyterLab extension. So all of this work and heritage that's gone into this Chart Studio online plot editor is now going to be available in the JupyterLab extension in an offline environment as well. The next piece of background is JupyterLab itself. So I would imagine that most of you are probably familiar with the classic Jupyter Notebook as an interface for doing interactive computing and visualization. JupyterLab is a newer project by the same team behind the Jupyter Notebook, and it's the next generation interface for these same use cases. So in JupyterLab, you have this, it's still in a browser, but you have this paneled interface that provides a lot more components that let you open different kinds of file types and have more options for configuring your workspace. So you still have notebooks, and the classic notebook interface is still preserved here. This particular notebook is one that I went over in my last webinar introducing plotly.py version 3. And as before, you can have a mixture of Markdown and code, and you can load data, you can display plots. This is the figure widget that was introduced in plotly.py version 3. So just quickly make a plot and show you that you have the same flow you had in the classic notebook where you can build these visualizations. Some new things that JupyterLab adds is you can do things like extract the output of cells. This is option to create a new view for an output cell. You can do things like move these output cells around. It has this very nice paneled interface, so you can drag and drop panes around and arrange your workspace the way that you want. That's one component of it. You still have a notebook, but in addition to the notebook, JupyterLab gives you this file browser over here and lets you deal with a lot of other kinds of file types. So let me, for example, open up this README file. So this README file is a text file. It's in a Markdown format. This is the standard plotly.py README file from our project. You can see when you open it, by default, you get the text editor view. But you can also right-click on a file from the file menu, go to Open With, and if there are multiple renderers supported for that file type, you'll get options under this Open With menu. So here I have an option to open it with the Markdown preview. And now I have a live rendered view of the same file, and I can, again, drag this around and have multiple ways of modifying or viewing and modifying the same content. So if I edit something in the Markdown file, I change Quick Start to start here, that automatically updates the rendered Markdown file. Another quick example that I think is pretty cool is CSV files. So for a CSV file, you can open it as a standard text file, as I'll do here. But there's also a built-in renderer to render this as a table. So I'm showing these examples just to give you a flavor for the kind of JupyterLab to deal with more file types in sort of rich, more interactive way. And then finally, you can also just open and view PDFs and have all these file types inside the same interface and deal with them that way. These alternative renderers for the CSV file and for the Markdown file, these come with the base installation of JupyterLab. But JupyterLab is a really rich and powerful extension system. And so it's possible for developers to add new extensions to integrate new components into JupyterLab and new kinds of file types and lots of options for customizing the interface. That brings me to the chart editor. So the JupyterLab chart editor is actually a fairly small amount of code that has the job of basically stitching together the chart editor component that was written for initially for the Plot Chart Studio interface, stitching that together inside JupyterLab to make a interface for editing Plotly plots. So the extension is on GitHub. The core underlying editor extension is also on GitHub. And if you want to get started later on, I recommend for installing everything here that you follow the installation instructions in the plotly.py README. The reason I say that is because there are a lot of moving parts involved in JupyterLab. There are a lot of, for this setup, there are a bunch of Python packages you need and a bunch of JupyterLab extensions that you need. And there are pretty detailed instructions here about all the versions that you need to get set up and get going. So that's where I recommend starting to play with stuff yourself. All right, now we'll jump back to JupyterLab and open up Chart Editor demo. Okay, so for this example, I'm going to make a simple, start with a simple plot of the wage inequality, or usually something's called the Gapminder data set. So here I'm loading this wage and GDP information. I'm just going to filter it down to only the year 1982. I'll initialize an empty figure widget. And then I'm going to create a separate scatter trace for each continent in this data set. So there's a little pandas operation here. I'm going to group the data frame by the continent column. And then for each continent, I'll add a scatter trace to my figure. The size is mapped to the population. And the y-axis here is mapped to the GDP per capita. And the x-axis is mapped to, encoded to the life expectancy. So now I've gone through this process. I've loaded some data. I've made this initial plot in plotly.py. I have the data on the chart. From here, if I was working purely in Python, I would go through a process of refining the chart. I would set up the axes and take care of a lot of these fine-tuning tweaks I'd like to make the chart look the way I want. But now there's another option. So the other option now is to do this sort of fine-tuning process in the chart editor. The first step to get the file into the chart editor is to write this figure out as a file. So starting in plotly.py version 3.3, there has been added this method, write JSON, in the plotly.io module. And that allows you to write a figure to a JSON file like that. So now I've created a JSON file called gapminder plotly.json. And that file is over here. And this is just a text file. I could open it with the text editor. It's a bit messy, but it is just text. It is just the data, the content of the figure itself is all in here. But what's more useful now is I can open this with the Plotly editor viewer. Now I'm going to collapse the file menu so this takes up the whole screen. So now I have my same figure opened up in the editor. And again, this process was all done offline, and the data is stayed all inside JupyterLab. And now I want to show you a series of edit operations you can do. This is only going to be a small sampling of the kinds of edits you can do in the editor. But I'm going to run through some ones that I think are interesting in this particular case. So to start with, there are some edits that can be done directly on the figure itself. So I can click on the x-axis location, and I can just type in, I want this to be life expectancy. I can spell that right, okay. I can type on the y-axis, I want this to be GDP per capita. I can do something similar for the title. So let's just name this life. This was from the year 1982. That process of just typing into the labels, I think is a very convenient thing to do, especially if you are outputting a lot of charts kind of in advance in an earlier process, and now you've gotten to the point where you want to build a presentation or something, and you realize you want to change the title to be a little different context. It's nice to be able to do that just interactively without having to have a live Python kernel involved. Just open it up and make these small adjustments. You can do other adjustments that are a little more related to the data itself. So let me switch this y-axis to a log scale. To do that, I'm going to go to the Style dropdown here and find Axes. And under Axes, I will look for this range extent. This is where I can set how the range is determined. I'll open up, set it to configure the y-axis and change from linear to log scale. Now I get a little bit more of a separation. It's a little easier to see the dispersion of the points in this view. There was a question on the chat of whether the chart editor supports 3D plots, and yes, it does. It does support the 3D chart types as well. So now I've made this a log axis, I can do some work with the colors as well. So I'm going to go to the this general tab, and there are options here for the default colors that are used for traces. So by default, when you add multiple traces, or in this case, multiple scatter traces to a plot, Plotly will cycle through colors for you, and it has this default cycle that it chooses, this blue, orange, green, red, purple, that it chooses it by default. But you can you could go through and change each trace individually, or you can just change to a different theme or different cycle itself. So here I can just sort of scan through these different combinations of colors and pick one that I like. I'm going to jump down to this dark 2 theme for these purposes. Let's look at a few other edits you can make. If I jump down to the traces themselves, I'm here under Style, styling the traces. I can make edits to all of the scatter traces at once. So I'll jump to this by type tab, and then I have the option to edit properties on all of the scatter traces together. Here is where I can make changes of things like what is going to be displayed. If I wanted to display the text along with the points, I could do that here. In this case, that's a bit too busy, so let me turn that back off again. I can update the opacity of the points that are displayed. So here I can change how transparent or how opaque I want these points to be. So I put it back to about 80%. And we'll go down to 75. The markers themselves have outlines, and those can be also changed. I change the marker symbol. In this case, I'm going to leave it round, but I could also add a border and increase that. I could change the border color. And in this case, I'm going to leave that as white. Put it on 2. Another question came in about whether these changes are also made to the underlying notebook. So at this point, I'm actually editing that file, that JSON file that I had saved to the file system. So I can pop the file browser up again. So I'm making edits to this file that I opened, but actually I haven't made an edit to it yet because I haven't saved the file yet. So this indicator right here on the solid dot that JupyterLab shows in the tab indicates that there have been changes made that have not been saved to file yet. So this is a similar workflow to what you would use with like a word processor or a text editor, where you open a file, make changes to it, and then they're not committed until you save them. So just to show you how this is going to work, I can preview that by saving this as a new file type, or a new file name. So I'm going to go to Save As, and then I'll pick a different file name. I'll just say gapminder-styled. Save that. That little dot went away, indicating that there aren't any outstanding changes. And then a new file type appeared here. So I'll keep making edits now. And as I save them, they'll be saved to this new gapminder-styled file. And then in a bit, I'll talk about how to get these back into Python and how you might want to do some more things with them programmatically after you make the edits in the editor. Let's do a little more with the styling. If you're familiar with ggplot, you might enjoy the style that ggplot uses, where the background of a plot is gray and white lines are used as the grid lines. So I'm going to go through and reproduce that style a bit. And so to do that, I'm going to go back to the General tab and look for the plot background and margin colors. For the background, I can show you an example of the color picker. So this is a component that's built in that you can use whenever you're setting the color of an element. And you have options to drag these colors around and just experiment with different color combinations. In my case, I'm going to go for a light gray for this background color. So I'm just going to adjust this. I can do it with the mouse, or I can go in here and enter RGB values themselves where I want them. So I'll do 245 for each of the RGB values. Great. And then I can copy this hex code color. I'll put this down into the margin as well, so I get the same color for both the plot background and the margin. Now I have this slightly light gray color as the background. Now to continue sort of the ggplot style, let me go to the axes and change the grid colors. So I can do that by jumping down to the lines entry of the axis panel. I change this to all because I want to edit the properties of all of the axes here. In this case, it's just X and Y. And now I can change the color. So now the color is this gray. I'm going to edit that color of the axis lines and make that white. And it is white now, but there's not a lot of contrast between the white lines and the gray background. So I'll go back to the background color and make that a little bit darker so that I can see the contrast a little more. So maybe something about like that. And then I'll put that same color again to the margin. All right, great. So now I have this different style to the plot that was set up now the way that I want it. Another place where I find the chart editor to be particularly helpful is in setting annotations. So when you're doing exploratory analysis, it's great to be able to hover over points. In this case, I configured this plot so that I could hover over the individual points and see the country names. But if you want to create a static version of this plot, or you want to put it in a paper or something, then it's important to be able to call out individual points using annotations to have a static representation of different features of the data that you want to highlight. These annotations can be set up using the chart editor by jumping down to the Annotations tab here and adding a new annotation. By default, it's placed kind of in the middle here, and I can drag this annotation up. I can point it at this point. This point was Saudi Arabia. And I can continue. I could add another annotation. But let me edit some properties here. So this annotation property, I can change the arrowhead to be a different style. I could change the color of the arrow, things like that. Let me add one more here. We'll handle the this larger one down that's also notable for its size and its location. That's China. Both the annotations are pretty intelligent about not allowing the line and the text to overlap each other, which is a nice feature. And one more change I'll make as I go is I want to add a title to the legend. These are different continents that are the color channel for this information. And I can do that by just dragging this legend down a little bit. I could add another annotation. And this time, this annotation, I'm going to remove the arrow. I don't need the arrow in this case. And then I can drag this up and use this as a title for the country. To do that, I don't want the annotation to be positioned relative to the data axes. I want to position it relative to the canvas so I can have it placed off to the side of the margin. So I'll bring this back. There we go. Great. So now I have a title for my legend, and I can make changes to it. I could change the font size, position it where I want. And these are all things that you could do from Python, but it's a lot more intuitive to use the mouse when you're trying to position elements and position annotations like this. Now the goal is, so we have a plot now. This is basically the way I want the appearance to look, but what can I do with this? So I want to work towards making this into a high quality image. From the editor itself, I can use the little camera button here on the plot itself to generate a PNG image of the plot. If I open that up, I have this PNG snapshot of the plot. This is a static version of it. But you don't have many options in terms of the quality of this version. So what I want to do is take this back to Python so we can use some of the newer options in plotly.py to save this as a high quality static image. The last thing I'm going to do in the editor is to specify the size of the figure. So when you're moving towards print, you want to kind of lock in the dimensions of the figure itself. So I'm going to change this to be 700 by 400. That's too small. And now I've done that, I'm going to adjust the annotations a little again with the new size in mind. Great. And now I'm going to save the figure. So I can just use the File menu to go File, Save File. And now in the File menu, this Gapminder styled plotly.json file has all of these edits in place. So I can close the editor out now and jump back to Python. And I'm going to read this modified JSON file. So I'm going to load in the Gapminder styled file. I'm going to load it in directly into a figure widget so I can just view it right away. And there we go. Now I have in Python the figure that represents all those edits that I made. I have access to all the data that I use in the editor. So like the styled layout title is still here. I can get access to that title that I use the mouse and keyboard to enter from the editor. And a couple of questions came in. I'll take a moment here to check out those. So the question is, how could you revert this back to Python code? So this is a really good question. It's something that I do want to figure out a smooth way to do. The best way right now to understand how to do this in Python code is to take a look at the representation of the figure. So if you just print out the figure, you'll get a definition of all the properties. And this really is something you can copy and paste into a new figure. But it's a long thing. It's a bit messy. So I would like to work through a process eventually of generating clean code based on the data frames to reproduce this. So that is a good suggestion. Another question was, can this be saved as a template to be reproduced for other cases as well? Very soon. Yeah, so the next version of plotly.py has some support to extract the style of a plot into a template and apply that to other figures. This is one of the features that's coming up in the hopefully the next week or so. We're going to release plotly.py 3.4 that'll have this templating feature. So yeah, stay tuned for that. Another question was, what versions of the notebook does this work well in? Is it only for JupyterLab? Yes, this is only for JupyterLab. This is taking advantage of JupyterLab's extension system. So you will need to run this through JupyterLab. And I'll come back to questions in a moment. Let me finish up the last couple things I wanted to show. The last thing I can do is, now that I have a styled figure, a couple of the ways I could share it is I could save it to a standalone HTML file. So here I'm using the plotly offline plot command. I'm going to save it to an HTML file. And that file is now available in my file menu. I could open this in a new tab. Oops. Open a new browser tab. And I have a version of this file that's self-contained. I can email this around and give someone an interactive version of the plot. Or if the goal is to put this in a paper, or you need a high-quality image for a blog post or something, you can use the static image export support that was added in plotly.py version 3.2. This is taking advantage of the Orca project to save this figure to a static, in this case, a static PDF file. And this PDF file shows up in the file menu as well. I can open this up. And what's really exciting about this format is that this is a high-quality vector format. So as I zoom in, you can see that everything stays sharp. Let's back out again. So this allows you to have a high-quality vector format of this plot that you built in Python originally. You edited it in the chart editor, and now you can export it into a vector format that's suitable for publication. All right, that's the last part of the demo that I want to show. We'll keep looking through the questions until we the last couple minutes that we have here. So another question was, can the content of the hover be changed using the interface? Yeah, so there are a few options you can change in the interface. So for example, in style, I go to traces by type. There's an option of what to display in the hover tooltip. So, oh, that's actually not hover. Here it is, on hover. So by default, it displays all this information in the hover tooltip, but I could turn off the X and Y values and just display the text if I wanted to only display the country name. Right. My question was about how to get a high resolution image on paper. I think we answered that through the Orca export process. That gives you, you can get a SVG, or you can get a PDF. You can also export to a high quality or high resolution PNG or JPEG file. My question is, are the arrows linked to the objects? The arrows are specified, annotation arrows are specified in data coordinates in this case. So they're linked to a location in XY space, not necessarily to a point. So when you specify them, you give them a location in your coordinate frame. The last question do we need a Plotly account for this? No, there's no need for a Plotly account for this JupyterLab workflow. This is all done offline. This is all using totally open source, MIT licensed technology. The data stays on your local machine. The only thing you need the internet for is the installation of everything. And the JupyterLab installation process requires the internet to get the extensions. But the data itself is all stays offline here. All right, and we are out of time. I'll hang around in the chat for a few minutes afterwards. And I think there's time for one last question. I think this is an interesting question. The question was, are PDF and 6Z or other LaTeX export formats supported as well as the PDF? So the other format besides PDF that is supported is EPS. And that is a vector format as well. And you need to have the popular library installed for that. So PDF and EPS are going to be your best bets for the publication process. All right, thanks for coming out, everyone. I will see you all next time.